19 and 6 more. I think I'll put that up here. 19 plus 6 more.
The teacher in this second grade class asked the students to make 25 with 2 add-ins. After recording some of their ideas, she asked them to consider something that has come up before. What happens if we change the order of the numbers in addition?
These 2 numbers that we used, can we switch them around?
Yes.
Can we change the order
Yes.
and still get 25?
Yes.
So how many people think yes? I hear a lot of yeses. Okay. Who's not sure? Is anyone not sure about that? So one person's not sure. So someone who's sure that they can take 2 of the numbers that are up here and change the order, I'm wondering, how would you explain that? How would you explain? All right, Raquan, you're going to use a big voice now. How would you explain? Tell us what number you're thinking about.
18 plus 7.
So you're thinking about 18 plus 7, okay? So what are you thinking?
Change it around.
And if I change it around, what will it be?
7 plus 18.
7 plus 18, okay? So what do you want to say about that?
Still going to be 25.
And how come that's going to be 25?
We didn't change the numbers.
Does anyone else have another one they want to talk about? Ashante?
19 plus 6.
Okay, so let's find that one. It's way up here. So if I put the 6 first and then the 19, what will it be?
It will be 25 because it's going to be the same number because you're just switching the numbers around. You're not adding any more numbers or taking away any numbers. You're just changing them around.
So are you sure we can do it with all these numbers here? You think that if we switch them around, any number that we have here that makes 25,
Yes.
we can switch them around?
Yes.
Well, suppose I asked someone in the class here if they could prove that. Could you do something or show me something that could kind of prove it or explain it better to me, that it does work? Here's the question. It's about changing numbers around. We had the equation 23 and 2 more, and someone gave us that equation and said it was 25. So we're wondering if you take the 2 and you put it first, and you say 2 plus 23. Do you still get 25?
Yes.
All right, but I want someone to. It doesn't matter. Why?
Because if you keep on just switching it around, it'll still make 25. Because if you're just changing one, you're not taking away or adding nothing to it. Because then that will still be the same number.
Okay. We had the equation 23 and 2 more.
Although these students are using an example with the particular numbers 23 and 2, they are making general statements that can apply to any number. That because nothing has been added or taken away, the order of the add-ins doesn't matter. Now, the teacher presents some problems with numbers that are too large for these second graders to add up easily. She wants to see if they can extend their arguments when they can't actually carry out the addition.
So I'm going to go back to this one, though. What if I take the 266 and put that first, and then put the 175 second? Let's just take a little survey. How many people think that if I put the 266 first and the 175 second, that my answer is still going to come out to this 441? How many people think that will happen? Okay, does anybody want to say what they're thinking? Then we're going to move on to something else. Okay, someone I haven't heard from. Anab, over here?
You see, the numbers are still going to be the same
Okay,
because
say it louder so everyone in the room can hear.
you see, because the numbers are going to be the same. If the numbers are the same, so it must be the same answer.
All right, so why don't you use the marker, because I noticed you kind of pointing to things, and explain what you meant about the numbers are the same.
This number and that number are the same. And this number and that number are the same, so that it's going to be the same answer.
So maybe you might draw lines and kind of match them up to show which numbers are the same.
These two and these two.
And so what else is going to be the same?
This one.
All right, so maybe you want to fill that in, so you think that the total or the sum will be the same.
It is because you're just switching it around.
Yeah, because nothing changes. Only that one number goes to first.
Why are you thinking 4?
Because.
Later in the discussion, the students think about switching numbers in subtraction. Some young students assume that if they can change the order of the numbers in addition, they can change the order in other operations. Here, students present their arguments about why subtraction is different.
That if you have 3, take away 7, but 3 doesn't have 7. So you can only do 7 and 3 because 3 is not a 7.
There's not enough in 3 to take away 7? Is that what you're kind of saying?
Yes.
So how many could I take away?
If you had 7, then you can do that one.
What if I had 3 and I wanted to take away 7? How many could I take away?
You can only take away 3
I could take away 3.
to make 0, but
Yeah.
if you did want, you can take away 4, or you can take away more.
Yeah, so there's something about what Regis was saying about this 4. And so Ashante.
I think that you can't use the 3 because after you use the 3, 2, 1, 0, 0, 0, it's gonna keep on repeating itself until it gets to 7.
Say the last part, it's going to keep on.
The 0 is gonna keep on repeating itself when it gets to 7.
Oh, so when I go back, I get to the 0, and I'm still at 0? It keeps repeating? Okay, so we've done a lot of good thinking here. This is a really difficult question. Last night, when I was with some teachers and we were talking about, this was a tricky question for all of us to think about, but you know what? You've done some really hard thinking and come up with some ideas. Did you want to say one thing? Because your hand was up, LaGuardia.
That won't be 0, that'll be -4.
Why are you thinking that? What's -4?
That means you're going lower. If you're going lower than 0, that means -1, -2, -3.